Welcome to this course on Microsoft Azure Fundamentals, AZ900. If you are preparing for Microsoft's Azure Fundamentals exam, this course is right for you. The AZ900 exam is designed for candidates looking to demonstrate foundational level knowledge of cloud services. The AZ900 certification is beneficial for both non-technical people and technical people. This course covers various cloud concepts such as the benefits of cloud services, the differences between private, public, and hybrid computing. You will learn the difference between concepts like platform as a service, infrastructure as a service, and software as a service. You will also learn the difference between a virtual network or load balancer, and all the concepts which will enable you to clear the AZ900 exam. So let's move on to our first chapter on this series. Let's start this chapter with an understanding of what cloud computing is. Most people and companies use this term probably without an understanding of it. In this chapter we'll learn about what cloud computing is, and what benefit it has to offer. Traditionally, if we ever have to build applications, we had to procure a lot of hardware. For example, you'll need servers, you'll need operating systems, their licenses, you'll need firewalls, router switches, load balancers, databases, and the list just goes endless. And that means you will need a lot of capital expenditure. On the other side, operational expenditure is what you will need to maintain that hardware. Small and medium business companies do not have the scope to invest so much. They resort to something called as cloud computing. This is where the whole bunch of resources will run. So the startups will simply put their resources, for example, servers, storage, databases, softwares, artificial intelligence and their respective analytics, everything into cloud. Cloud is nothing but a massive humongous data center that is maintained by the cloud provider. And the best part is, the CapEx and OpEx really falls down exponentially. You typically pay for the cloud services only what you use. The company providing these services is referred to as cloud provider and the user is called cloud user. The cloud provider is responsible for all the physical infrastructure, like the physical hardware, and they are also responsible for the hardware that's required to execute your work, and keeping it up to date with patches and antivirus. The services mostly include compute power, such as Linux or web applications. They also include storage such as files and databases, secure connections, and also analytics of compute storage and network, so that you get the visual telemetry, performance data. The goal of cloud computing is to make running a business easier and more efficient. Whether it's a startup or a large enterprise, every business is unique and has different needs to meet. Now that we know the definition of cloud computing, let's also understand the benefits of cloud computing. There may be two kinds of organizations that would want to select cloud computing to build their infrastructure. One is the startup companies who lacks on infrastructure. Others are existing businesses who might want to choose a gradual movement from the on-premise to the cloud to save money and get all the benefits and good features of cloud computing. Cloud computing is a cost-effective solution, primarily because it provides a way to pay as you use the services. We can also call it as a consumption-based pricing model, because you really do not have to pay any upfront predefined amount for the computing resource or hardware. It's just like renting the hardware, you just use it, and then, once you're done, you give it back to the cloud provider, then you pay for just that amount of time you've used it. This consumption model would bring several benefits because there are no upfront costs. There is no need to purchase or manage the costly infrastructure. The ability to pay for additional resources only when they are needed, and you can stop paying for resources when they are no longer needed. Another advantage is scalability. You can increase or decrease the resources or services based on demand. Consider that there is e-commerce application, and there is a sale going on, and that sale will lead to a spike in traffic overnight. Because the cloud is elastic in nature, the cloud computing provider will automatically allocate more resources to handle the increased traffic, and when the traffic begins to normalize, the cloud computing provider will automatically allocate the resources to minimize the costs. Cloud is reliable. When you are running a business, you want to be confident of your data, that it is always going to be there. That means availability is handled by the cloud provider. The cloud computing provider will provide data backups, disaster recovery, and their replication services, to make sure your data is always safe. In addition, redundancy is often built into cloud services architecture. So if one component fails, a backup component takes its place. Cloud services is a big shift from traditional way of how businesses think. In this video, we'll talk about the key terms used in cloud computing. The first one being high availability. High availability is the ability to keep the services up and running for long periods of time, and the businesses must make sure that there is very little downtime depending on the service in question. Scalability and elasticity. We spoke about scalability and elasticity in the previous video. Adding capabilities to manage an increase in demand to an existing resource is called scaling out or scaling up. A distinction between scalability and elasticity is that elasticity is done automatically. Agility. Agility is the ability to react quickly. Cloud services can allocate and deallocate resources quickly. Global reach. It means that the cloud services can reach the audiences around the globe. Finally, security, and that's not least important. Cloud providers offer a broad set of policies, controls, and expert technology that can provide better security than most organizations can otherwise achieve. The result is strengthened security, which will help to protect data applications and infrastructure from potential threats. Cloud models. Number 1. Public cloud. A public cloud is owned by the cloud services provider, who is also called as a hosting provider. In this case, it could be Amazon Web Services, Microsoft Azure, or Google Cloud Platform. The cloud provider is a service provider, and they provide resources and services to multiple organizations and users. Second, private clouds. When we think about the term cloud, it always doesn't mean that it's with a third-party provider. It could be within your organization as well. Private clouds are owned and operated by companies that uses the resources from that cloud. The organizations or enterprises will create their own cloud environment with their own data center. That means the resources, hardware, storage, and everything else that's required to make a cloud is within the data center of the enterprise. Hybrid clouds. The last one is hybrid cloud. A hybrid cloud combines both public and private cloud environments, and that means that hybrid clouds will allow you to run your applications in most appropriate location. An example of hybrid cloud usage scenario would be hosting a website in public cloud and linking it to your highly secure database, hosted in your private cloud infrastructure. Hybrid cloud scenarios are very useful when organizations have some things that they do not want to put on public cloud.
What do you mean by platform as a service, software as a service, and infrastructure as a service? Infrastructure as a service. Do you know what it takes to build an infrastructure for an organization? And when we think about infrastructure, think about the underlying components of any application. For example, a server hardware is like routers, switches, firewalls, the underlying cabling, and then everything that goes with the physical infrastructure. You need a lot of security monitoring, log access, load balancing, clustering, storage, resiliency, backups, and this list can just go endless. These are the services that an application will need for it to function properly. The infrastructure as a service provider will supply this range of services to you as a service. So, you do not have to go ahead and create that infrastructure on your premise. Infrastructure as a service is the most basic category of cloud computing services. With infrastructure as a service, you rent the infrastructure servers, virtual machines, storage networks, and operating systems. The user is responsible for installation, configuration, and management of the software inside that operating system. But the cloud provider is responsible for ensuring that the underlying cloud infrastructures, virtual machine, storage, and networking is always available for the user. Platform as a service. Platform as a service provides an environment for building, testing, and deploying software applications. Let's understand this. Developers are responsible for building great applications that we have today. They are very good at writing great code and making sure that the application works and performs at its best. But one of the major roadblocks that developers have is, they do not have an understanding of the underlying infrastructure where the application will be hosted. For example, the developer may not know what encryption is and what backups are. The platform as a service provides an environment for building such applications so that the developer does not have to worry about those concepts and can focus on writing the best code. For example, when deploying a web application using platform as a service, you do not have to install an operating system. You do not have to even take care of the Windows updates or install the antivirus on the machine. Platform as a service is a complete development and deployment environment in the cloud. The cloud user, or the developer, is responsible for the development of their own applications. However, they are not responsible for managing the server or the underlying infrastructure. The cloud provider is then responsible for operating system management and network and service configuration. Software as a service is a method of software delivery that allows data to be accessed from any device with an internet connection and a web browser. In this SaaS-based model, software vendors host and maintain the seller's database and the code that constitute the application. First, the companies do not have to invest in extensive hardware to host the software. And this in turn allows buyers to outsource most of the idea responsibilities. A major benefit of SaaS is being able to spread out costs over time. Some of the examples that you can talk about is Office 365, which is a cloud-based email delivery model from Microsoft. The other examples are Salesforce, Facebook, and Gmail, because you do not have to install anything. All you need is a browser and a login with the user and password given by the cloud SaaS provider. In this module, we'll talk about Azure's architectural competence. Microsoft Azure is made up of data centers located around the globe. These data centers are organized and made available to end users by regions. A region is a geographical area on the planet containing at least one, but potentially multiple data centers. When you deploy a resource in Azure, you have to choose a region where you want to deploy your resource. This provides the customers the flexibility and skill needed to bring applications closer to users around the world. It also offers comprehensive compliance and resiliency options for customers. Each Azure region is paired with another region within the same geography. This approach allows replication of resources. This replication of resources, like virtual machine or storage, is done across the geography. That helps reduce the likelihood of interruptions that are caused due to events such as natural disasters, civil unrest, power outages, or physical network outages. Data will continue to reside within the same geographic. We now know about geographies and regions. Let us understand what availability zones are. Availability zones are physically separate locations within the region. Each availability zone is made up of one or more data centers that are equipped with independent power, cooling, and networking. So that means, if one availability zone goes down, the other continues to work. The availability zones are typically connected with each other through very fast, private fiber optic networks. Availability zones allows customers to run mission-critical applications with high availability and low latency. Resource groups and resource management. In Azure, you can create different kinds of resources, like virtual machines, web applications, databases, etc. But there will be some point when you would like to group those resources, and that grouping of resources is called as a resource group. In Azure, you can think of a resource group as a container that would allow you to keep all the resources inside it. Then you will be able to manage them more effectively. For example, you can check the billing of that resource group. A resource group will let you effectively manage the application collectively, as it becomes difficult to manage objects individually. So how are the resources created in Azure? The resources in Azure are created through the Azure Portal, PowerShell, Azure CLI, REST API, or a Software Development Kit, SDK. Resource Manager is a management layer, in which the resource groups, and all the resources within it, are created, configured, managed, and deleted. Thus, it allows you to automate the deployment and configuration of resources, using different automation and scripting techniques. Azure Compute Service. Azure Compute is an on-demand computing service for running cloud-based applications. It provides computing resources such as disks, both SSD and regular HDD, processors of different kinds, memory of different configurations, networking, and operating systems. The resources are available on demand, and that can typically be made available in minutes or even seconds. If you want to use Linux and Windows virtual machines in seconds, with the configurations of your choice, you can create virtual machines. To achieve high availability, by auto-scaling, to create thousands of virtual machines in minutes, you can do that through virtual machine scale sets. Azure Kubernetes simplify the deployment, management, and operations of Kubernetes. You can accelerate app development, using an event-driven, serverless architecture, through Azure Functions. Quickly create cloud apps, for web and mobile, with fully managed platform by using Azure App Service. You can easily create highly available, scalable cloud applications, and APIs, which help you focus on apps instead of hardware through Azure Cloud Services. Azure also have container instances, batch, and an Azure dedicated host too. You pay only for the resources used, and only for, as long as you are using them. In this video, we will learn, how do you create a virtual machine, using the Azure portal. We want to create a virtual machine. So let us click on the Virtual Machine section, and then click on Create Virtual Machine. Let's create a new resource group, and name the new resource group in our virtual machine. Now here you can see the Azure data centers. Now you need to choose where you want to create this virtual machine. Select one of these geographical regions. The best practice is to choose a virtual machine that is closest to the user. Then you may want to choose an availability option, to make sure that it's available at all times, and doesn't get affected in events of disasters. Because in this case we are just creating a test environment, so we'll leave the available option at this time. The next option is to choose the kind of operating system. Now this virtual machine is being created somewhere out on one of the Azure data centers, which we selected just right here. Azure Containers. Traditionally, if you had to install applications, then the first thing that we had to do is to create either a virtual machine or a physical machine. Once the machine is ready, you will then have the dependencies installed, and then the application sits on top of the dependencies. So, we create multiple layers, starting from the application dependencies. Then comes the operating system. And finally, the hardware. Now, containers and virtual machines have a similar resource isolation and allocation benefits, but they function a little bit differently, because containers will virtualize the operating system. The virtual machines will virtualize the hardware. Containers are more portable and efficient. Now, as you see in the picture here, there is a container managing application, or container engine, for example, Docker, which can manage multiple containers. Each container will then host application and its dependencies, as you see in the picture. Application 1 and 2 have different set of dependencies, or binaries, or libraries, but still they are sitting on the same virtual machine. Containers take less space than virtual machine. Whereas virtual machines are abstraction layers on the physical hardware. Each virtual machine includes a full copy of the operating system, the application necessary binaries, and libraries, which will take tens and hundreds of gigabytes together. Virtual machines can also be slow to boot. But containers are very quick, they can handle several applications and require very less virtual machines, and few operating systems. So containers and virtual machines have similar resource isolation but function differently, because containers virtualize the operating system, instead of virtualizing the hardware. Containers are portable, efficient and very quick in running the application. Let's learn to create, configure, and deploy a Docker container to Agile container instances in Azure Portal. The container is created from an image template, called as Microsoft ACI Hello World. The image package is nothing but a small web application written in Node.js, and serves a static HTML page. Let's get started with creation of containers and container instances. Log on to Azure Portal, and search for containers in the search box. Click on it, and you will be prompted to create a container instance. You can click on Create Container Instances, or click on the plus add button on upper left side here. Once you click on it, you will see a screen that will prompt you to fill up several fields. Starting from resource group, container name, the region, image type, image's name, operating system, and size. Then click Next to select the ports. By default, you will see port number 80. And because this is a public instance, we would like to have a public IP address associated to that. Also make sure that you have DNS name label typed in, because this is what we will use to access that application in the container. Now click Next, and configure the restart policies. Docker provides a restart policy to control whether your container stopped automatically when they exit, or when Docker restarts. Restart policies ensure that linked containers are started in correct order. Now, tags will help me create a configuration management database. Now click on Create to create a container instance. So the deployment is complete, you can now go to a resource. Azure Virtual Networks. Networking is an essential component of any infrastructure. Networking on Azure allows you to connect cloud resources with each other, and also with other on-premise infrastructures. Azure networking is also called as VNet, which stands for Virtual Networks. The isolation segmentation allows you to filter the traffic based on what you want to allow in the Azure networks. Let's create virtual networks. Follow the instructions which follows. Azure Load Balancer. When you create web applications, you need to ensure that the users get 100% uptime for the applications they are accessing. This cannot be achieved with a single web server, because if that web server is down for maintenance, or for any other reason, then the end users will have difficulty accessing their application. Organizations would create multiple web servers and put them behind a load balancer. The load balancer absorbs the traffic and evenly distribute the traffic originating from various regions to the web servers hosted in your data center. Azure Load Balancer ensures that the applications hosted on your data center are highly available. The Azure Load Balancer can be used for traffic originating from the internet, and also for the internet-based applications. Azure Storage Services. Organizations use storage on servers and on external storage devices. They sometimes need to host databases like Microsoft SQL or NoSQL, like DocumentDB or Cosmos DB, and also other type of data like documents, videos, etc. So now let's understand how Azure can accommodate these kinds of data. Azure provides storage in the form of blob storage, disk storage, file storage, and archival storage. The blob storage is meant for unstructured data. That means there are no restrictions on the kinds of data it can hold. These blobs are highly scalable, and you can put unlimited amount of data inside. The applications can then use the data for reading and writing purposes. Blob storage are very powerful. They can manage thousands of concurrent loads, massive amounts of video data, and constantly going log files, and they can be read from anywhere. A blob could contain gigabytes of stream data for any purpose. The disk storage provides disks for virtual machines. Just like the name says, it provides disks for virtual machines applications, and other services. Every time you create a virtual machine in Azure, the storage account which will be provisioning the disk, will be inside a disk storage. A file storage is used to manage file shares. Now these file shares are accessed using SMB protocol. Azure file shares can be mounted concurrently by cloud, or on-premise deployments, of Windows, Linux, or even Mac OS applications running in Azure. Virtual machines can mount a file storage share to access file data, and a number of virtual machines can mount and access the file storage share simultaneously. Archival storage provides a storage facility for the data that is rarely accessed. It allows you to archive legacy data at low cost. Archive storage is available as a tier of blob storage. Archival storage is stored offline and offers the lowest storage costs. However, it also has highest access cost. That means that you should not be accessing that data in the archive of storage very frequently. Azure Big Data and Analytics. When we talk about big data, we are referring to a large volume and large amount of information. This amount of data becomes increasingly hard to make sense of, and traditional forms of processing and analysis are no longer appropriate. Azure supports a broad range of services and technologies to provide big data and analytical solutions. Some of the most common big data and analytical solutions in Azure are Azure SQL Data Warehouse, HD Insight, and Data Lake Analytics. Azure SQL Data Warehouse. Azure SQL Data Warehouse is a cloud-based enterprise data warehouse. This uses massive parallel processing, also called as MPP. It is used to quickly run complex queries across petabytes of data. You can use SQL Data Warehouse as a key component of a big data solution. Azure HD Insights. There are several open-source software utilities, like Apache Hadoop, Spark, that facilitate using a network of several computers to solve problems involving massive amounts of data and computation. HD Insights will let a business run such open-source framework on its Insight platform. HD Insight is a cost-effective enterprise-level service for open-source analytics. You can effortlessly process massive amounts of data and get all the benefits of the broad open-source ecosystem with the global scale of Azure. In addition to this, HD Insights also supports data warehousing, machine learning, and IoT. Azure Data Lake Analytics. Azure Data Lake Analytics is an on-demand analytics job service that will simplify big data. Instead of deploying, configuring, and tuning your hardware, you write queries to transform your data and extract valuable insights out of it. The analytics service can handle jobs of any skill instantly by setting a dial for how much power you need. You only pay for your job when it is running, making it cost-effective. The Data Lake Analytics dynamically provisions resources and lets you do analytics on terabytes to petabytes of data, and you pay only for the processing power that is used. Azure IoT Hub. The Internet of Things is becoming an increasingly growing topic of conversation. It is a concept that not only has the potential to impact how we live, but also how we work. But what exactly is Internet of Things? Broadband internet is becoming more widely available. The cost of connecting is decreasing. And more devices are being created with Wi-Fi capabilities and sensors that are built into that technology. Costs are going down. The smartphone penetration is skyrocketing. So, the Internet of Things is the concept of basically connecting any device with an on and off switch to the internet. This includes everything from cell phones to coffee makers to washing machines to headphones, lamps, wearable devices, and almost everything else as you can think of. Two of the core Azure IoT service types are IoT Central and Azure IoT Hub. Azure IoT Hub is a managed service which is hosted in the cloud, and this acts as a central message hub for bidirectional communication between your IoT application and the devices it manages. You can use Azure IoT Hub to build IoT solutions with reliable and secure communication between multiple millions of IoT devices. You can connect virtually any device to your IoT Hub. Azure Machine Learning. Machine learning is an application of artificial intelligence that will provide the systems the ability to automatically learn and improve from experience, without being explicitly programming. The primary aim is to allow the computers learn automatically, without any human intervention or assistance, and then adjust its actions accordingly. Microsoft Azure will let us create a machine learning environment, in the form of Azure Machine Learning Service and Azure Machine Learning Studio. The Azure Machine Learning Service will help us develop, train, test, deploy, manage, and also track the machine learning models. It uses open-source technologies like TensorFlow, Scikit, Jupyter Notebooks, and also Visual Studio Code tools for artificial intelligence. The machine learning service from Azure also includes features that will automatically generate models and help you create models with ease, efficiency, and accuracy. There is a lot of manual things in machine learning service. That's where the Machine Learning Studio comes in. Machine Learning Studio is a collaborative, drag-and-drop visual workspace, where you can build, test, and deploy the learning models, and you really do not have to write in a code here. Because it's all pre-built, and pre-configured machine learning algorithms. Serverless computing. Serverless computing promises the possibility of ideal business implementations with focus on your application, and not on your infrastructure. The objective is to reduce the time to market your application. A lot of work goes in implementing, maintaining, debugging, and monitoring the infrastructure. If we keep all of that heavy lifting of the infrastructure out of the way, we can just focus on business goals. So does serverless computing mean that there are no servers? Absolutely not. It just means that the cloud provider dynamically manages the allocation and provision of the servers. That means that you do not have to keep the servers ready for your code deployment. It is the cloud provider that creates and manages their servers for you when you trigger the code deployment. Azure provides serverless service in the form of Azure Functions, Azure Logic Apps, and Azure Event. Azure Firewall. A firewall is a service, or a device, that will let you access certain resources. The firewall looks at the originating IP address on each request, and then it allows to access, or delay, depending on whether you have blacklisted a particular IP, or a port. Azure Firewall will provide several features, including inbound and outbound filtering rules. And you can integrate it with the monitoring service called Azure Monitor, and then look at all the logs that the monitor will give to you. Common use case scenarios for having an Azure Firewall implemented into a virtual network is to have application rules defined in the network, so you can have your virtual machines accessing a particular IP range or a website. Azure Data. Imagine running a corporate environment, but lots of sensitive data. There would be competitors, and people of malicious intent, trying to steal that information. There will be others who would be using tools to disrupt your business and services to your customers. In today's environment where lots of corporations are adopting cloud, the cloud provider take enough precautions against such malicious adversities. Microsoft Azure has a service called Azure Data Protection that protects us against such malicious adversaries. Basic data protection is automatically applied for U subscription. The standard tier can protect against volumetric attacks, protocol attacks, and resource layer attacks. Volumetric attacks is where the goal is to flood the network layer with lots of substantial amount of seemingly legitimate traffic. Protocol attacks is where these attacks render our target inaccessible by exploiting a weakness. Resource layer attacks will target the application packets to disrupt the transmission of data between hosts. Azure Information Protection. Microsoft Azure Information Protection is a cloud-based solution that will help organizations classify and protect the document and also emails by applying labels. Labels can be applied automatically, manually, or with a combination of both. Here's an example of Microsoft Azure Information Protection in action. In this example, the administrator has configured a label with rules that detect sensitive data when a user saves a Microsoft Word document containing, let's say, a credit card number. A custom tooltip is displayed. A tooltip recommends labeling the file as confidential, which is a label that an administrator has configured. This label classifies the document and also protects it. After your content is classified, you can then track and control how the content is used. For example, you can analyze the data flows to gain insight into your business. You can detect risky behaviors, take corrective actions, track access to documents. You can also prevent data leakage, or even misuse of documents, by properly labeling them. Azure Security. While we provision different kinds of resources in Azure Cloud, there must be some kind of a service that helps us identify the potential vulnerabilities in our Azure subscription. Azure Security Center will identify the vulnerabilities across our Azure subscription and also provide threat protection. Azure Security Center provides security recommendations based on your configurations of resources. You can also define a list of allowed applications to ensure that only the apps you validate are allowed to execute. You can analyze and identify potential inbound attacks and help to investigate threats and any post-breach activity that might have occurred. Security Center will provide just-in-time access control for your ports. That will reduce your service attack by ensuring the network only allows traffic that you require. Azure Your Security Center comes in two versions, free and standard. The free one is available as part of your Azure subscription. Monitoring applications and services. What is the point of having a monitoring service if it does not provide visibility of the operations in your environment? Azure Monitor include several features and tools that provide insights into your applications. Let's talk about more features of Azure Monitor. Azure Monitor features can be organized into 4 categories. These categories are Analyze, Respond, Visualize, and Integrate. The analysis can be done by Agile Insights. Now, as Insights is a service that monitors the availability, performance, and usage of your web applications. They could be hosted on the cloud or on your premise application. Insights leverages the powerful data In addition to allowing you to analyze your monitoring data interactively, an effective monitoring solution must also respond proactively to any critical conditions. This might involve, for example, sending a text or email to an administrator, who is responsible for investigating an issue. Monitor alerts will proactively notify you of critical conditions, and can potentially attempt to take corrective actions as well. Although scaling will ensure that you had the right amount of resources running to manage the load on your application, effective visualization is so important, so you can then look at charts and tables, and these are effective tools for summarizing the monitoring data. Azure Monitor has its own features for visualizing monitoring data. Finally, you can integrate Azure Monitor with other systems, and build customized solutions that use your monitoring data. There are other Azure services that can absolutely work with Azure Monitor to provide this integration.